Welcome back, everybody. This is episode 12 in my multi-cloud network architecture series. And in this episode, we're going to integrate the Meraki SD-WAN solution with the Aviatrix cloud networking platform. I've invited special guest, a colleague of mine, Hari, to walk us through a real-world use case that he came across with one of his customers where they were trying to integrate Meraki, and he built a really beautiful solution for them with the integration with Aviatrix. And so I want to thank Hari for being here with me today. Let's get started.
Dana, thank you for having me. I'm super excited to be here. And you're right, we are here to talk about how we can integrate SD-WAN by Meraki into various cloud providers. The issue that, problems that the customers run into is, yes, they can connect multiple sites where they have Merakis into their cloud provider using an auto VPN solution by deploying a VMX100 instance in their respective cloud provider. But it gets a little complicated when you want to scale the solution, i.e., if you want to connect into multiple VPCs or VNets in each of the cloud providers, it gets a little complicated because the alternative is to have spin up a VMX100 in each one of these VPCs or VNets, and that gets really expensive and not scalable very quickly, right? Imagine a customer trying to do over 15 or 20 or even hundreds of VPCs. Those are pretty common these days. So scaling that meant that you needed to find a way to connect this VMX100 auto VPN hub into a transitive solution, right? So that was step one. How do we do that? We've figured out a way to connect the VMX100 into the Aviatrix encrypted transit that we provide in AWS and Azure and other clouds.
Fantastic, Hari. I love this design and I love the solution that you came up with. And I'm really excited for you to show it to everybody. But I just also want to say that this is something that Aviatrix is dealing with on a daily basis. These types of requirements and problems that around SD-WAN integration, for example, that's coming to us on a daily basis, and we're solving them all the time. If you guys have watched my other videos, we've done it with VeloCloud and Silver Peak and Cisco, Viptela. Pretty much any SD-WAN solution, we can add functionality and augment and add intelligence to the network. Really what's happening is that when you terminate your SD-WAN at the edge of the cloud using a native cloud construct like a VGW, for example, or a TGW, you're losing all the intelligence of your SD-WAN, all the scale and automation, because the moment it hits the cloud, it becomes kind of dumb because cloud networking in of itself is really basic. So what we want to do is integrate an intelligent SD-WAN with an intelligent cloud networking platform from Aviatrix. So I'm really excited to look at this in more depth. I think you have a diagram that goes into some depth here, right?
Yes, that's a great segue into the actual design diagram. And to your point, you're absolutely right? Aviatrix has managed to bridge that gap when networking transformed from the physical world to the virtual world to cloud. There was that architectural gap, i.e. lack of visibility to the underlay. And we've been able to work with native constructs and build on top of that, and that's very important. You can take this and it fits right into our multi-cloud network architecture, and your video series is a testament to that.
Love it.
So this fits nicely into our network architecture for the cloud. Now, let's take a deeper look at the design itself. This is built with Aviatrix controller, and most of you are familiar who've seen this video series on how to deploy and maintain all of that. You can use Terraforms or APIs to interact with our controller. Let's say you've deployed and you also know how to use our transit network workflow to deploy our encrypted transit network. You have that in place. Now comes along the Meraki connections. You have VMX100 deployed in your network. And you're wondering how you can connect this into all your other existing VPCs or VNets. And the solution really is pretty simple. You can build a non-Meraki VPN from the Meraki point of view to the transit network gateways. And from Aviatrix standpoint, that would be a site-to-cloud policy-based tunnel. We are able to build that. Once you build that, Meraki community has well documented methods on how you can redistribute all of those auto VPN routes you get from the various sites into your non-Meraki VPN, right? It's achieved by inserting one other hub in between your non-Meraki VPN and the main hub. And once you do that and go through the setup of that, you're now able to redistribute all of those auto VPN routes into this non-Meraki VPN. Right?
Okay.
Once you advertise that into the transit network, our controller is intelligent enough to redistribute that as needed based on security policies to the spokes that need it, right? So various spokes are now able to reach these on-prem routes via the Meraki because the controller is intelligent enough to redistribute those routes as needed to the spokes that require it.
Got it.
Now, let's talk about really quickly about how to achieve HA and redundancy, right? When you have connections coming in with the same, subnets from your on-prem, as you see here, the Meraki is advertising that same route to this Meraki hub. And you also have an on-prem router that's advertising the same subnet directly to the transit. When you advertise things like that, native constructs don't let you quickly pick one over the other. It gets routing issues, etc. So solving that active backup, preferring one over the other, and if one goes down and pushing the traffic onto the other becomes really key. And that's also achieved in this design simply by inserting another pair of transit gateways. Once you do that, now you create the non-Meraki VPN to this transit, let's call it the landing transit, and then you create what's called a transit appearing from that landing transit to your actual transit. Boom. Because the SDN functionality of the controller has the intelligence to pick local routes over this transit of routes, we are able to now achieve that active backup.
That's key. Right? That's key, right? So there's a path decision algorithm or mechanism in our controller to pick the local routes through the direct connect, which is a higher throughput, lower latency, SLA-based connectivity back to on-prem over the Meraki internet-based auto VPN tunnels, right? So if the direct connect goes down, everything fails over to the Meraki. Is that correct?
That's exactly right. And we'll see this in our demo when we get to it, you're absolutely right. They prefer these high bandwidth, more reliable connections, but something goes wrong, it goes away. Traffic will switch over to the Meraki over that internet as a backup until you can restore your prime.
And what about sites that have only Meraki? They're going to be able to go directly to the cloud, right?
That's exactly right. From a Meraki standpoint, it doesn't matter. It'll just build an auto VPN to Meraki only sites or to the on-prem that have both. And those routes will land in this auto VPN hub, and it'll be redistributed to our landing transit. And because for Meraki only sites, the subnet will only be heard via this landing transit to your main transit, that will continue to be your path.
Yeah, that's awesome. Love it. Yep. Love it.
So that's exactly how that is achieved. Just because we hear that same subnet through this reliable local route, that's always preferred. And if that fails, it fails over to the Meraki. If that subnet is only heard over this connection, this transit connection traffic will still flow through that. So you achieve both in the same design.
Yeah, and once you've done this in one cloud in one region, you can move it to another region, just copy it, and you can move this to also multiple clouds, other clouds. And so it's the same repeatable design for your multi-cloud network architecture, and that can be deployed by hand, clicking things in the UI, or just a Terraform script, right?
Absolutely right, Dana. This is why I wanted to show that this is possible in multi-clouds, AWS, Azure, and it's the exact same design, exact same normalized data plane across different clouds that's buying you this intelligence via the same controller. And so you're absolutely right. It's the same design across any cloud, any region.
Yeah, this is brilliant because, in my opinion, you get all the control you had on-prem, all the visibility that you're used to having in normal networking, you have it in the cloud, but we don't add any additional complexity. We're handling all of the complexity behind the scenes for you and just presenting this to you as simple configuration workflows or constructs in our UI or in our Terraform. So it's so brilliant because we remove the complexity. We're adding a lot of functionality, but we're having that balancing act of not adding additional complexity, and that's really important to most customers.
Perfect. Yeah, that's actually a good segue. Why don't we go look at the configurations?
Yeah, let's do that.
This is how our controller looks. It takes 15 to 20 minutes to deploy. Pretty easy. They're all automated. Once you've deployed it, you onboard all your accounts. This is multi-account, multi-subscriptions, multi-cloud. And so you can do all of that in this account section. Then the transit network workflow, this is where you would actually deploy encrypted transit network in Azure or even in AWS and other clouds. It's pretty simple. You put in all the information here about your VPC and subnets and pick the gateway size. And then boom, you create the transit gateway. We always recommend doing an HA for that. And once you've done that, now you've actually created the transit gateways for your main transit network. Then you can actually start launching spoke gateways if you want and tie them all together by just peering them. And once you attach a spoke to the transit, now you've actually created the transitive network in the cloud, right?
So in your diagram, can you show me quickly on your diagram what exactly we would have just built there in 10 minutes?
Yep. What we just built is all these multiple different VPCs. Now you create the transitive network for your entire AWS workload, or same thing for your Azure workload. No matter how many VPCs you have, you just quickly build that encrypted transit network. And that's what we just built. So we just built inside the cloud.
Awesome.
Once you're done with that, then you can actually come to the site to cloud page. This is basically where you would build site-to-site VPNs to on-prem or to any other device. So in our case, like we mentioned, we're going to create this connection to the Meraki, a policy-based VPN connection to the Meraki hub. And the way you would do that is you would just hit add new, you would fill all the information, and our documents are amazing. Just go to docs.aviatrix.com and search for VMX100, it will come right up. Follow those directions. You punch in the IP address of the VMX, PSK, local, remote subnets, hit OK. And here's an example of the connection that I've created that's up and running.
Wow.
Right?
So easy.
That's right. That's how easy it is to create it. In fact, you can download the config and use that to match it on the Meraki side. How would you create it on the Meraki side? It's anyone who's done, non-Meraki VPN before, this is pretty straightforward. You would put the local networks that you want to advertise to the Aviatrix side right here. And then you would come here and build, add a peer and put that peer's name, public IP, the subnets that you're going to reach from the Aviatrix side, the PSK. And this is important. You want to make sure that you choose custom, and then you want to choose AES 256.
Okay.
And then both for phase 1 and phase 2, SHA-1 as well, and then PFS Group 2. Lifetime is can be kept as it is, 28,800. And you hit that, and then you hit save. Make sure you hit save. Boom, then you created the peer on your Meraki site. If you're having any concerns, our APIs are a great way to interact with our controller. Deploying the same site to cloud that you deployed via UI, you can deploy via API or Terraform. I would also highly recommend using Yanch so it fits into your CI/CD pipeline. But this is how you would configure this on the Meraki site. I am assuming that the audience knows how to deploy AutoVPN. That's not part of this. So you set up the AutoVPN, all those routes come to Meraki. But what we just walked through is how you would set up this non-Meraki VPN towards the Aviatrix site. So if I go back to the diagram, we just built that non-Meraki VPN from the VMX100 to the transit device. Now, to achieve the whole design, we talked about inserting this extra pair of transit gateways. It's the exact same thing that we did the first time. You would just deploy the gateways and stop there, right? You're not going to be peering any spokes. You would just deploy the gateways and stop. And here's that transitive peering, going back to the Aviatrix controller. It's as simple as coming to transit peering and hitting add new. Choose your transit gateways that you just deployed, right? The one that connects to all your spokes and the other one that connects to your Meraki. You would peer here and boom, you're done. That's it. And now those routes are exchanged between the two transit devices.
Okay.
And, it's there for you to use it.
Okay. So just as a quick recap here, you create the main transit network, main transit environment that you have here on the left, that where your direct connect is connected to, and then there's kind of a landing transit it's the same workflow that we just went through to create the normal transit. Then you peer them together, right? You just do the normal transitive peering. They talk to each other. We handle all the routing, all the IPsec between each other. And then there's also a site to cloud tunnel, which is just a generic VPN tunnel between the Meraki VMX100 and the landing transits. Now, question for you, Hari. In your diagram here, I see two VMX100s. What is the reason for two VMX100s in that Meraki VPC? Can you talk about that again?
Yes, absolutely. Good question. So the whole idea of that second VMX100 is so you can redistribute the routes you learn from the AutoVPN VMX100 hub, right? So if you look at more details, this VMX100 here is the one that's doing the AutoVPN to all your on-prem sites.
Yeah.
Those routes will now be in this. There's no clean way, because of lack of support on the Meraki side, to redistribute those AutoVPN routes to a non-Meraki VPN, right? So that's really the big, one of the limits. But that limit has been overcome. This is documented in Meraki community. Is you insert another VMX100, do point-to-point interface between them, exchange those routes, and then build a site-to-cloud tunnel, non-Meraki VPN from this new hub to the Aviatrix.
Okay. So it's a problem with the origin of the route. If you can't take the origin of an auto VPN route and redistribute that into a standard IPsec VPN connection, instead you have to go from a standard or from just a normal non auto VPN route. Then you can redistribute that into standard VPN tunnel. Correct?
That's exactly right. Yeah. Okay. So it's auto VPN routes coming from all your on-prem, whether it's Meraki only or both Meraki and some other on-prem.
Got it.
And then that lands into this auto VPN hub. In order for you to redistribute those routes into your cloud, you need that extra VMX there, so that then that can be distributed into a non-Meraki.
Well, that's a cool workaround. So I hope that in the future Meraki will actually lift that limitation. But for now, that works.
Cool. Dana, why don't we actually do a demo of this and we can see how failover happens. And I will show the instances here in a second, but let's quickly walk through the lab setup, right? So the source is going to be this test instance in 10.100.0.90. That's going to simulate all your production workloads inside your cloud. The destination is going to be 10.199.213. That's going to be simulate your on-prem. Now, the primary path is this BGP IPsec tunnel to this test instance. And the secondary path is actually via the Meraki to that same instance, right? These are all set up. I'll show the route table here in a second where you can see it. What we're going to do in the setup is that I'm going to insert a dummy subnet, insert the actual test instance subnet on this primary path. What that's going to do is that this path is effectively fails for this subnet. And so traffic will then switch over to this transitive peering and it'll flow over the Meraki.
Got it.
So that's what we're going to show in the lab setup.
So it'll take the next best available path, which is through the Meraki. So it knows that the primary path went down because you put a dummy subnet there. You removed the real one, put a dummy subnet, and it's going to try to figure out, well, what's my other path to get to that 213? And it knows there was an alternate path through the transit network to the Meraki.
That's exactly right. So there's an easy way to look at your route tables in Aviatrix Controller is you go to the transit network list and choose the gateway, and you can hit show table. Right now you can see that that 10.199.213 is actually a learned CIDR, but it is not learned via the transit peering site, right? That's what's important to note here. You're learning it by a different way, the primary path, not over that transitive peering. That's key, right?
Yeah.
So what I'm going to do is I'm going to go to that site to cloud tunnel that I have as a primary path at the moment. It's going to be this one. And you can see that this is the remote subnet I'm reaching over the primary path as a remote subnet. I'm actually just going to change this to something just to show that this is a dummy subnet.
Yeah, and just for the sake of explanation here, usually you'd be using BGP from the cloud to on-prem. In this scenario, we're just doing a static IPsec tunnel with some static routes, just so you guys know. But in real world, BGP would be the exact same thing for you. If the BGP route got retracted, then of course there's no longer available path. The controller would reconverge and figure out the next best path. So same thing, we're just showing it in a static method.
That's exactly right, Dana. So let me start that ping. Right now this traffic is going over that primary path.
Yeah.
I'm going to go change this to some 222.
Some dummy subnet, yeah.
Some dummy subnet, it's changed. But you notice that the traffic is still flowing.
Yeah.
Right? The light increase. Right.
Yeah.
And the reason is because if you go back here, now if I look at that route table and I just do a refresh, you notice that now that same subnet is learned over the transit pairing.
Yeah, cool. Quickly, it did it instantaneously too. It was like zero, less than a second. It switched over.
No packet loss. It just keeps going, right? So note here. Previously, it was not being learned on the transit pairing. Now the traffic is switched over the transit pairing. So if I go back to this diagram here, initially it was learned over this tunnel, and that's why you were not seeing that in the transit learned CIDRs.
Yeah.
When I kill this, you saw that now that same subnet is learned over the transit CIDR, and that's because it's being learned over the transit pairing from our landing transit that's via the Meraki to the engine.
Yeah, very graceful architecture for failover, and it's very deterministic too. Those are two important things with networking and networking architecture, is a graceful solution as well as deterministic nature of it. You know exactly what's going to happen when a certain behavior occurs. Like if a link goes down, you should know exactly what's going to happen, and the controller did exactly that. So really nice to see it.
That proves that this active backup works, and we've also proved that we're able to build the site to cloud tunnel to the Meraki. That brings all that solution together, right?
Yeah.
At the end of it, we started off with the customer goals of being able to connect multiple sites, scale that, connect into a transit, and we are the site to cloud tunnel, and then achieve HA, have active backup, consider the Meraki as backup, and you're able to do all of that.
Great, Hari. This has been fantastic. I'm so impressed with the work you did here. That's why I invited you to talk to the audience today. And so I'm really gracious that you joined us. Thank you so much.
Thank you, Dana. This has been amazing. I love your series. I'm a big fan. Keep it coming.
Thank you. I will. Take care. That was a great session. I'm so thankful to have Hari on my team here at Aviatrix. He's always thinking outside of the box and leveraging the Aviatrix platform to come up with so many different cool solutions for our customers. I want to leave us with what did Aviatrix do for you slide, like I always do. In this Meraki SD-WAN integration scenario, Aviatrix provided dynamic routing and automatic failover between ingress and egress points in the cloud. Now this works for multi-region in the same cloud or multi-cloud. It's the same architecture. It doesn't matter where you deploy this. We were able to leverage the intelligence that comes baked into the Aviatrix controller for best path decision making and to automatically reprogram an alternate route when the primary path went down. The Meraki routes were advertised end-to-end within your cloud network without any user intervention. Now, since the Meraki tunnels are terminating on Aviatrix gateways, we're then able to provide visibility with packet capture, ping, traceroute, flight path, and copilot. I'm going to go into all of these in another video that's coming soon. That's it. I really hope you guys enjoyed this session, and we'll see you in the next one.